Hello again. We've got another set here where they're asking us, are these oxidations or reductions? We've done that before. There's also a new thing where they're saying indicate how many electrons per atom are gained or lost. So not just are we gaining or losing, but how many. And we find this by doing oxidation numbers. In something like C2O42 negative, we know that oxygens have a charge of -2 each. There are 4 of them, so that's a total of -8. But the total for this ion is only -2, so what are we getting from the carbon? We're going from -8 up to -2. The total here must be +6 from the carbons. But there are 2 carbons, so each of them is responsible for half of that amount. For the carbons, they should be +3 each. If you wanted to do this as an equation, I won't do this every time, but if you wanted to math that out instead of talking through it, you would write 2C plus 4 O's equals -2, and oxygen is -2 for charge, so we'd have 2C plus 4 times -2 equals -2. This is an equation you can solve. You add 8 to each side, 2C equals 6, divide by 2, C equals 3. That's how you can find the oxidation state for the carbon if you want to do it without juggling a bunch of numbers in your head. But typically, I am a juggler for questions like this, so I'm going to mostly do it that way. If this really bugs you, get a hold of your instructor and they can take you through it a different way. So, over on this side, those are our oxidation states. And before we go on with this, for questions like this where we're not only finding the oxidation state but finding how many electrons per atom, it is important for the reaction to be balanced before we go on. So here we have 2 carbons. We need there to be 2 carbons on the right. That may become a big deal when we're talking about how many electrons per atom. In carbon dioxide, the oxygens are -2 each, total of -4, yet the molecule's net charge is 0, so the carbon here must be +4. That's +4 total and +4 each because there's only a single carbon atom there. So, first, what happened to the carbon? Its oxidation state went from 3 up to 4, and if your state goes up, then you were oxidized or reduced. Up is oxidized. So the carbon was oxidized, meaning it lost electrons, and how many? Each carbon was +3, and it went up to +4, so 1 electron per atom. We're going to do stoichiometry with this later on. The fact that the carbon's charges went up by a single step means they lost 1 electron each. If they went from +3 to +5, that would be 2 electrons each, and so on. So that's the approach we're going to use for all of these. Okay, nickel. Oxygens are -2 each, total of -4. I'll put -2 each, -4. So because the net charge is 0, the nickel must be +4. Now over in this thing, this is the hydroxide ion. I can take all of this, because I know what hydroxide is. I can say hydroxides are -1 each. There are 2 of them, so that's a total of -2. And from that we get that our nickel is +2. You're allowed to do that with polyatomic ions if you know what they are. And if you don't care about the things inside them, you're more interested in what happens to something outside them, in this case the nickel. So, what happened to nickel? Its oxidation state was 4. It came down to 2. 4 to 2 is down, so nickel was reduced. And how much was it reduced by? From 4 down to 2 is 2 electrons per atom. Reduction is a gain, so each of these nickel atoms was gaining 2 electrons. That's our ratio. Chlorine, what do we have here? Oxygens are -2 each, total of -6, but the total for the chlorate ion is only -1, so this chlorine must be contributing +5. This chloride ion is just -1. There's nothing else to it. This charge that you see is what you get. So, what happened to chlorine? It went from +5 down to -1. chlorine was reduced, because the state went down. And how much was it reduced? From 5 down to -1 is a total of 6 steps. Chlorine gained 6 electrons for every atom. This is ethanol, and in ethanol we have a -2 charge from our oxygen. The hydrogens are +1 each, and there are 6 of them, so we have a total of +6 there. And then we have 2 carbons, and all that adds up to 0. I'll do an equation for this one just because it's a little more complex. 2 carbons, +6 from the hydrogens, -2 from the oxygen, and the grand total is 0 because there's no charge written here. 2C plus 4 equals 0. Subtract 4 from each side. 2C equals -4. Divide by 2. C equals -2. The oxidation states of the carbons are -2 on the left. On the right, oxygens are -2 each, total of -4, so the carbon must be +4. What happened to carbon? It went from -2 up to 4. Up is oxidation. And how far was it oxidized? From -2 up to 4 is 6 steps, so 6 electrons per atom. Every carbon lost 6 electrons during this. This one's got to be about phosphorus. The sodium isn't even mentioned over here. So we have -2 each from our oxygens. I can't just use the charge for the hydrogen phosphate ion, in case you're wondering, because it's stuff inside that ion that I'm interested in changing. So we can't count on that. That ion charge wouldn't tell me what I need about the P, although we are going to use it in a bit. Oxygens are -2 each, total of -8. This hydrogen is +1, and the sodiums are +1 each, total of +2. And then we have our 1 phosphorus. So I'll do an equation for this again. We have 2 from the sodium, plus another 1 from the hydrogen, plus whatever phosphorus is, plus -8, and all that adds up to 0. 3 minus 8 is -5. P minus 5 equals 0. Phosphorus is 5. That was kind of a clumsy equation, and there's a couple of things I could have done differently, but it'll be all right. The phosphorus oxidation state is 5. In PO2, oxygens are -2 each. That's a total of -4. The total is 0, so our phosphorus must be +4. Phosphorus started at 5 and fell down to 4. What happened to it? Phosphorus was reduced. And from 5 to 4 is only 1 step, so it gained 1 electron per atom. This one's got to be nitrogen because we didn't even carry the oxygen over to the right. These are not finished reactions, obviously. They're not balanced in most ways. We have -2 each from our oxygens, total of -6. So the nitrogens must be contributing +6, but there are 2 of them. So each nitrogen has an oxidation state of +3. And in ammonia, hydrogens are +1 each. That's a total of +3. For this to get back to 0, the nitrogen must be -3. And you can put each there if you want, but there's only 1 atom, so it would be true whether you wrote it or not. So nitrogen went from +3 each down to -3 each. It went down, so nitrogen was reduced. How much was it reduced? From +3 down to -3 is a difference of 6 electrons per atom. The nitrogens gained 6 electrons per atom. X is not an element. Xe is, that's xenon, but this is something made up. So for this thing, this is going to be weird. We have oxygens are -2 each. There are 5 of them, so total of -10. but the ion charge is only -4, so this element X, or ion X, must be giving us a total of +6 charge. And in this, hydrogens are +1 each. So we're getting a total of +3 from our hydrogen. Yet the total is 0, so ion X must be giving us -3. X went from +6 down to -3. What happened to it? It was reduced because its state went down. How much was it reduced? From +6 down to -3 is a difference of 9 steps, 9 electrons per atom. And finally, this is potassium permanganate. We have oxygens are -2 each, total of -8. Potassium is +1. It's a type group 1 metal. They don't know how to do anything else. And then we have Mn with a charge we don't know. The total has to come out to 0. 1 plus Mn minus 8 equals 0. Mn minus 7 equals 0. Mn equals 7. I'm not sure we needed an equation for that, but whatever works. Sometimes I'll go to equations if the thing's even a little complex to keep myself from making mistakes. Over on the right, MnO2. This is like CO2 or anything else. -2 each for the oxygens, total of -4. The other thing must be +4. So what happened to manganese? It was +7. It fell to +4. If you fall, you are reduced. Manganese atoms were reduced. How much were they reduced? From 7 down to 4 is 3 steps, so they gain 3 electrons per atom.